Hello, welcome to this second video on uniform distribution. In the first part, we saw about what is the definition of uniform distribution, why it is called as by the other name called as rectangular distribution, what are its parameters, the mean and the variance, and we try to solve some simple problems using the basic definition. Now we will move on one step ahead to solve word problems using your uniform distribution. The problem is as such: buses arrive at a specified stop at 15 minutes interval starting from 7 a.m. So they arrive at say 7, 7:15, 7:30, 7:45 and so on. A passenger arrives at a stop at a random time that is uniformly distributed between 7 and 7:30 a.m. We have to find the probability that he waits for less than 5 minutes for a bus and at least 12 minutes for a bus. Okay, so the case is like you have the period of waiting time. Say suppose this is going to be the waiting time at exactly say 7, 7:15, 7:30, 7:45. You're going to have buses of such kind. But a passenger arrives at what duration? The arrival of the passenger is between 7 to 7:30. Between 7 to 7:30. So where is our range? Our range of working is from 7 to 7:30. This is going to be the interval in which we are going to observe the passenger for. Okay, so he can arrive at any point of time between the 7 to 7:30. We are not very sure about it. We know just the interval of working. In which case we say that if x is going to be denoting the time in minutes past 7 a.m. when the passenger is to arrive at the bus stop, then what will happen? We know that he can arrive at any point of time over here. So that is going to be uniformly distributed between 7 and 7:30. We are noting the time in minutes. So this is going to be 7:00 minute, 0 minute, and this is going to be 15 minutes. So x is going to be uniform in. X is uniform in the period. What is the period? 0, 30, because in minutes this is going to be 0, 0 and this is going to be 15 and this is going to be 30. So this is going to be between 0 to 7 to 7:30 he is going to arrive. So uniform in 0 to 30. In which case what will be our f of x? So our f of x will now be equal to 1 divided by b minus a. So this becomes 1 divided by 30 minus 0 for your 0 less than x less than 30. Hence the function is 1 by 30. Now coming to the first case. What is the first case saying? He has to wait for less than 5 minutes. Less than 5 minutes. So less than 5 minutes he has to wait. But if he is going to come exactly at 7, will he be catching that bus? No, that is not possible. So the 7 o'clock catching the bus is going to be ruled out. Now not to disturb the original baseline, we will have one more baseline here. Okay, we will make it clear. This is going to be 7. This is going to be 7 a.m. This is going to be 7:15 a.m. and this is going to be 7:30 a.m. Now he cannot catch the 7 a.m. bus because he has to come 5 minutes prior to it to catch it. He is only arriving at 7. So this catching 7 o'clock bus is going to be ruled out. What is the second option available for him? He can catch the 7:15 bus. But for catching the 7:15 bus, he has to wait for less than 5 minutes. So he must have waited only for 4, 3, 2, 1 or 0 minutes. So in which case at what time he must have entered the bus stop? He must have entered the bus stop between 7:10 to 7:15. Only in which case he must have waited less than 5 minutes to catch the bus. So this is going to be one case. Or he has entered past 7:15, after 7:15. So he would not have caught the 7:15 bus. So what is the other chance available for him? He has to wait for less than 5 minutes for the next bus. The next bus is at 7:30. So 5 minutes prior to it, where will it be? It will be at 7:25. So he must have entered the bus stop between 7:25 to 7:30, in which case he will wait for less than 5 minutes. So these are the two options available for him to wait less than 5 minutes. Therefore, let us put it in probability. Therefore, the required probability is going to be probability of waiting between 10 less than x less than 15 minutes, that is this duration, or so you put a plus sign for your or between this duration. So probability of 25 less than x less than 30. So how is this to be evaluated? Integral from 10 to 15 f of x dx, and this is evaluated at integral 25 to 30 f of x dx. Now what is our f of x? F of x is 1 by 30. So integral from 10 to 15 1 by 30 dx plus integral from 25 to 30 1 by 30 dx. Now we'll move on to the next slide. So what will happen? 1 by 30 comes outside as common. X is going to be the integration of dx between, where does he wait? Between 10 to 15. So between 10 to 15, or again 1 by 30 times of integral dx is x. Where does it wait? Between 25 to 30. So between 25 to 30. Now on integration and applying the limit, we have this as 1 by 30 is common for both the cases. So let us take 1 by 30 outside. The first one is going to be 15 minus 10, plus the second one is going to be 30 minus 25. So this is going to give me 5. This is going to give me 5 divided by 30. So this makes it as 10 by 30, or the answer will be 1 by 3. So the probability that he waits for less than 5 minutes for the bus will be equal to 1 by 3. So this completes the first subdivision. Let us now move on to the second subdivision. What is going to be the second subdivision asking us? He has to wait for at least 12 minutes for the bus. 12 or more than 12 minutes for the bus. So let us mark it in the next slide. So this is going to be our 7 to 7:30 slot. So this is going to be our 7 a.m. So this is our next 7:15 a.m. and the last one will be at 7:30 a.m. So he has to wait for at least 12 minutes to catch the bus. So he must have waited for at least 12. So more than 12, equal to or more than 12. So it is greater than or equal to 12. So he must have waited for 12 or 13 or 14 or 15 minutes to catch the bus. So what is happening over here? He could have arrived prior to 7. So catching the 7 a.m. bus is again ruled out. Hence what we will have to do is from 7:15 let us travel back. So if we are going to go for 12 minutes, so where he would have arrived at, he must have arrived between 12. So this is going to be the 15th minute, this is going to be the 14th minute, this is the 13th minute, and this is going to be the 12th minute. More than 12 minutes. So he has to wait for at least 12 minutes or more than that to catch us. So from 7:15, if I am going to move backward by 12 minutes, then at what time he must have entered? He must have entered between 7 to 7:03, because from 7:03 to 7:15, how many duration is there? This is going to take 12 minutes. So 12 or less than that. So it is going to be 12, 13, 14, 15. So he must have arrived between what duration? Then he will wait for more than 12 minutes. So if he has arrived between 7 to 7:03, he will wait for more than 12 minutes. More than 12 minutes. Now, if not this scenario, he has left the bus, he hasn't entered it between 7 to 7:15. So he has left the 7:15 bus. Now the only option for him is catching 7:30 bus. If he has to wait for more than 12 minutes to catch the 7:30 bus, then what time he must have entered between? So going 12 minutes in the backwards. So if I go 12 minutes in the backward, what will happen? 30 minus 12, that makes it as 18. So what happens? He must have entered between 7:15 to 7:18. If he has entered between this duration, then he will wait for at least 12 minutes to catch the bus. So what are the two options available for us? Therefore, what is going to be the required probability so that he waits for more than 12 minutes? It is the probability of arrival between 0 to 3 minutes, or it is the probability of arrival between 15 to 18 minutes. So these are the two options available for me. Okay, so now moving to the integration part. This is integral 0 to 3 f of x dx, and the second case is integral from 15 to 18 f of x dx. So this is going to be integral from 0 to 3 1 by 30 dx plus 1 by integral from 15 to 18 1 by 30 dx. So you can take your 1 by 30 outside as common. So if I take 1 by 30 common outside, then what you will be left out with? You will be left out with x between 0 to 3 and 1 by 30. So you will be left out with integral dx is x between 15 to 18. So taking 1 by 30 common outside, you will have 3 minus 0 plus this is going to be 18 minus 15. So this is going to be 3 and this is also going to be equal to 3. So 3 plus 3 is 6 divided by 30. What is 6 by 30? 6 by 30 will go how many times? So this is going to be 1 by 5. So the probability that he waits for more than 12 minutes to catch a bus will be 1 by 5. I hope you understood this problem. Thank you.